In this video, we're going to find and classify the stationary points on the curve y is equal to 2x cubed minus 3x squared minus 36x using the second derivative test. Now we're going to do this without drawing, but we're going to use the drawing to sort of help us work out what the steps would be. So I've got this GeoGebra app, and I'll put the GeoGebra app in the notes of this video. So here we have our curve, y is equal to 2x cubed minus 3x squared minus 36. So we're going to try to locate that point and that point algebraically. First of all, if we click here for the tangent, okay, so the orange line here represents the tangent at any point. So if I move the slider here, we can get different points of P. We will notice at the actual maximum point here, we have that the tangent, the gradient of the tangent will be equal to 0. We've got a horizontal straight line. And similarly, here we have a horizontal straight line at the minimum point here. So in order to find stationary points, or turning points, we will need to find dy by dx. So we need to differentiate this function and put that equal to 0. So if we got y is equal to 2x cubed minus 3x squared minus 36x, step number 1 is to find dy by dx, the gradient function, like I just explained. We know if y is equal to ax to the n, then dy by dx means take the n, bring it down in front, write down the a, and then reduce the power of x by 1. So applying that to each of these, so we have dy by dx is going to become 2 times 3, which is 6x squared, minus 6x. And if you differentiate minus 36x, you get just minus 36. Right, next step is to put dy by dx equal to 0. So we take this and put it equal to 0. So we've got 6x squared minus 6x minus 36 is equal to 0. We notice a common factor of 6 here, so we'll take that out. And then we will factorize what's in the bracket. Okay, so if we factorize that, we're just going to get x, and the factors of 6 are 1 and 6, 2 and 3. I want minus 3 in the middle, so I think I'm going to have a 2 and a 3. This one will have to be minus, and this will have to be plus. Okay, it is a really good skill in mathematics to make sure that you can factorize a quadratic. Right, that was going to give me values of x. X plus 2 is equal to 0, so x is minus 2. Or x minus 3 is equal to 0, x is equal to 3. Right, now we're going to do is now use the second derivative test to test these points. But before we do that, let's just see why that works. So going back to my GeoGebra app, if I click here, I get the graph of the first derivative of this function. Okay, at this particular point, which I know to be a maximum point, I see that the dy by dx is equal to 0, which is what we've just shown, at minus 2. But if I look at the gradient of the gradient, it is negative. Okay, similarly here, where I have a minimum point, dy by dx is equal to 0, but the gradient of the gradient is actually positive. So that means if I differentiate a function, find the stationary point by putting dy by dx is equal to 0, and then if the gradient of the gradient, i.e. the second derivative, is negative at that particular point, then I can say I automatically have a maximum point. Down here, if I have differentiated and found that 3 is a turning point, i.e. the gradient is equal to 0 here, but if the gradient of the gradient is positive, then this point will be a minimum point. And this is called the second derivative test. Now we can look at what the second derivative looks like. It will just be a straight line in this case. But I can see that the gradient of the gradient is negative at this point. In fact, it's minus 30 at this point. So therefore, if the gradient of the gradient, the second derivative, which we write like that, is negative, then that point will be a maximum point. And here, at this particular point, where dy by dx is equal to 0, the gradient of the gradient will be actually plus 30. The second derivative will be at plus 30 at that particular point, and therefore it is going to be a minimum point. So these here are the values that I'm going to find. I've already found -2 and the 3. I'm going to actually find 44 minus 81 later. But here is what's known as the second derivative test. So if dy by dx is equal to 0 and the second derivative is negative, then I have a maximum point. If dy by dx is equal to 0 and the second derivative is positive, then the point is a minimum point. Now we have one problem with this, that if dy by dx is 0 and the second derivative is 0, then I cannot actually determine whether I have a maximum and minimum point, and you have to go back and use the first derivative test, which we've done in a previous video. Because this point could be a maximum, could be a minimum, or it could be what's known as a point of inflection, a stationary point, which is a point of inflection, which we'll talk later about. Okay, so this is the rule for the second derivative test. So we found dy by dx, and we found our two x values, -2 and 3. Now we're going to use the second derivative to determine that that is a maximum and that is a minimum. So going back to this, so use the second derivative test. Now notation, d dx of dy by dx, that's dd, so it's d squared y over dx squared. This is the notation used for the second derivative. So if we had that dy was equal to 6x squared minus 6x minus 36, if we differentiate again, we just do the same thing. 2 times 6, which is 12x. Differentiate minus 6, you get 6x, you get minus 6. Differentiate minus 6, 36 with the constant, you get nothing, so we're not going to write that in. Now what we say is when x is equal to -2, we put that in there. So the second derivative will be 12 times -2 minus 6, which is minus 30, like I told you. So this is negative, but we have dy by dx equal to 0. Therefore, this is negative. Therefore, we can say automatically that x is equal to -2 is a maximum point. And then when x is equal to 3, do the same thing. The second derivative will be 12 times 3, so putting x3 in here, minus 6, which is equal to plus 30, which is positive. But therefore, this point is a minimum point. It's sort of the opposite to what you might think it would be. So negative, maximum, positive, minimum. We'll look at the case when it's equal to 0, what to do in a different video. Okay, so if we now find the y coordinates, we've got y is equal to 2x cubed minus 3x squared minus 36x. So when x is equal to -2, we're going to have that y is 2 times -2 cubed minus 3 times -2 squared minus 36 times -2. If you're doing this on your calculator, you must make sure you substitute the negative number using brackets on your calculator, otherwise you'll make a mistake, particularly with that one. So make sure when you're substituting negative numbers, you put them in brackets. That will give you 44. And when x is equal to 3, you're going to have that y is equal to 2 times 3 cubed minus 3 times 3 squared minus 36 times 3. And that will give you minus 81. So the conclusion will be that the maximum point minus 244 and the minimum point is 3 minus 81. So if we go back to the graph just one minute, okay, so we've got a maximum point at minus 244 and a minimum point at 3 minus 81. Like I said, this GeoGebra applet I will put in the notes of this video. I hope you've understood. So this has been a video about how to use the second derivative to classify turning points. I hope you've understood, and I thank you very much for watching.